Alrighty, the next idea we need is something called a unit vector. A unit vector, the idea of it is that it's sort of like it gives us a direction, and that's the most important part. The magnitude, the length of it doesn't really matter. So we just take the length to be equal to 1. So any vector whose length or whose magnitude is equal to 1 is a unit vector. So, whoopsie. Let's try that again. This is a definition. If we have a vector v, it's a unit vector if and only if the length of v is equal to 1. That's it. And of all the unit vectors, two special unit vectors, because we're working in a coordinate system in R2, so if we create our coordinate system, there's sort of two special directions in R2. There's the direction that goes directly to the right, and the one that goes directly up. That's along the x-axis and along the y-axis. And we call these vectors, the ones that are unit vectors of length 1 in each of those directions, by special names. So they're called I and j. And we usually, instead of putting the dot on the I and the j, we just put that little vector sign. I is the one that goes in the x direction. It is the one 1, 0 are its components. And j is 0, 1. This is I, and this is j. Here and here. Okay. Two special unit vectors. All right. Let's go ahead. What do we do with unit vectors? Well, one idea is just, if I give you a vector, can you tell me the unit vector that goes in the same direction? So if we look at part A here, let me give myself coordinate axes. And trying again. So the vector that we're talking about here is the vector, let me see, part A. This is the vector 8, 6. So if we go over 1, 2, 3, 4, 5, 6, 7, 8 on the x, and then 6 on the y, it's the vector here. This is our vector 8, 6. Now, is this a unit vector? Well, I can tell just by looking at it that the length is way longer than 1. Length 1 would be down here some way. So I would say this is not a unit vector. How do we make it into a unit vector? Well, what we would like to do is just kind of shrink it without changing the direction until it gets as short as a unit vector. To do it, let's just first calculate what is the magnitude or the size of this vector. So the magnitude of the vector 8, 6 is equal to, well, it's the square root of 8 squared plus 6 squared. That is the square root of 64 plus 36, which is the square root of 100, which is 10. So this vector 8, 6, it has length 10 or magnitude 10. And to be a unit vector, what we would like is to have the same direction, but shrink it down so it's only of length 1. And here's how we do it. We use the observation from before, which is when you do scalar multiplication of a vector, if you multiply by a positive number, then you don't change the angle of the vector, but you do scale that vector. You scale it to make it bigger if the number's bigger than 1. You scale it to make it smaller if the number's less than 1. Here we want to shrink it down by a factor of 10. And so what do? We multiply by 1/10. That will scale by a factor of 10 times 8, 6. This thing is equal to, well, let's see. If we multiply, this is 8 over 10. 8 times a tenth is 8 over 10. 6 times the 10th is 6 over 10, and of course we can simplify those a little bit. Canceling 2's out of the top and bottom, we get the vector 4/5, comma, 3/5. All right, this vector, so first of all, we're done, provided this is really a unit vector. So let's just check. Is it a unit vector? And to tell if it's a unit vector, we simply take the magnitude of it. That's the magnitude of the vector 4/5, comma, 3/5. And that is equal to, well, it's the square root of 4/5 squared plus 3/5 squared, which is the square root of, this one is 16 over 25, and this one is 9 over 25. We square the tops and square the bottoms. They both have the same denominator, which is handy. We can just immediately add them, and the top 16 and 9 does get us 25 over, and then 25. Oops, I wrote 24, which is not what I meant. Let's get rid of that. There we go. 25 over 25. And those, of course, cancel and give us, this is the square root of 1, which is equal to 1. So this is a unit vector, because a unit vector is just a vector whose length is 1. Okay? If we were to graph this vector on the same set of coordinate axes, it would look something like this. This is the vector 4/5, comma, 3/5. That's it for part A. Go ahead, pause, try and do part B, then come back, we'll work on it together. Part B is the vector -2, comma, 3 radical 7. So here is B. The vector is -2, comma, 3 radical 7. And we're going to find a unit vector. Recall the instructions. Find a unit vector in the same direction as our vector, but with length only equal to 1. And we're going to solve this in just the same way. That is, what I'm going to do is the same algebraic steps that we did here, but I'm not going to draw the picture. However, there is a picture that goes along with it, and it looks just like this one. The idea is we would draw the original vector, and then we would think about scaling it up or down until it reached the correct length, which is a length of 1. So what do we do? First, we find the length of this vector. The length of the vector -2, 3 radical 7, or the magnitude, is equal to, well, it's the square root of -2 squared plus 3 radical 7 squared. Squaring in the insides, that -2 squared is 4. To square the 3 radical 7, we first square the 3, that's 9, and we square the radical 7. Radical 7 squared just gives you plain old 7. So this is equal to radical 4 plus 9 times 7 is 63. And so this is radical 67. Now, 67 is not a perfect square. We can't take the square root of it, and it doesn't break up into anything nice. Is 67 prime? Not sure, but I know that I can't simplify it in any nice way. So this is the length of the original vector here, 2, 3 radical 7. And what we would like to do is, this is too long. Radical 67 is, well, it's less than 10, bigger than 5, bigger than 6, bigger than 7, bigger than 8. It's 8 point something. So we want to scale this vector so that it has length 1, and the length is currently this. What do? Well, if we multiply by 1 over this, that will scale this scale it down exactly enough so that the magnitude will be divided by this, and it will cancel out. And so the vector that we want is as follows. Here's our answer. It's 1 over radical 67 times our vector -2, 3 radical 7. Now, fact, you can leave it like this, right? Or we could multiply it by multiplying that 1 over radical 67 inside times each of the pieces here. It's up to you which way you want to leave it, which way you want to keep it. And I'm going to leave it like this for now, depending on what the problem is asking for. You may do that, or you may do something similar. All right, that's it for unit vectors.